And we are live. Welcome, everybody. Welcome to the first meetup 2022. And Happy New Year to everybody joining. So if you already joined, and we'll give this a few minutes to give people the chance to join. If you already joined, feel free to say hi in the chat. If you do that, maybe include your location and make sure to select to everyone before saying hi, because otherwise you're just saying hi to Josh, Nils, and myself, which is also nice, but I think it's better to, cool. And I see the first people saying hi. Hi from Munich, nice. Yeah, include your location. I think that's always interesting to see where people are from. So I'll give this 1 or 2 more minutes. Chicago, USA, nice. Oh, that's, yeah, Germany, Netherlands, UK. Cool, we have a Mexico, Munich, Turkey, nice. We have a very international crowd tonight. I love that. UK. So we're currently at 40 plus participants. We'll give this a few more minutes before we really get started. Maybe a few housekeeping rules before getting started. So this meeting is being recorded, as you can see. We are happy to share the recording with you tomorrow in an email together with some useful links. If you have questions, then either use the chat that most of you just discovered and place your questions there, or there's also a Q&A section available where you can place your questions. Placing them in the Q&A is always a bit better because questions don't get lost there, while they can get lost in the chat flow. We will have time for Q&A in the end, so we will have time to then actually ask Nils and Josh these questions. And maybe as a second thing, before really getting started, we prepared a short poll that I'm trying to bring up right now. It should be live now, where we are trying to get an idea on the audience today. And the question is, me debugging Kubernetes applications, piece of cake, okay, rather not, and Kubernetes question mark. So I see the first people filling out the questionnaire. Nice. I give this a bit more time to let questions come in.
And as a host or panelist, I can't vote. That's
no, you can't. No, you can't. I'm sorry for that, Nils, but no, you can't. It's always the same.
Okay, I'll talk about it in a second.
Try to tweak the result. That's not possible. All right, I close this in 5, 4, 3, 2, 1, and go. And here are the results. So, which you should be able to see. So we have 2 people today, at least, that say debugging Kubernetes, piece of cake. I'm the go-to person in my team company. Welcome. I think you're happy to also help us in the Q&A section later on. We have 27% okay, another 29 with I can do it, but it takes way too long. 15% with rather not, and we have 24% answering Kubernetes question mark, I never tried. So it's a good mix of different levels of experience. I think there will be something in for everybody today. So and with that, I'd say welcome again to this first meetup 2022. I'm Christoph. I'm your host tonight. I watch the Q&A section. I'm here for any technical question that you might have. In my working life, I'm also with Humanitech, as Nils is, and have the pleasure to run most of the webinars. And I'm very happy to have 2 guests here today, Josh and Nils. And this is going to be exciting because it's not only slides, we are going to see some real action. So the stuff that can go wrong. So if you ever organize the webinar, it's the stuff where you get sweaty hands. But let's kick that off. And I think I'll hand over to you, Nils, and leave the floor to you.
Thank you very much, Christoph, and welcome everyone. So I'm the lead QA engineer at Humanitech. Part of my daily job is actually debugging web applications running on Kubernetes. And I'm doing that not only to report issues, but I also want to find the root cause of each issue to make it as easy as possible for developers to fix those issues. So when I basically found out about Rookout, I was quite excited about the possibilities we are going to talk about today.
Perfect, perfect. So first off, thanks to the Humanitech folks for having me. My name is Josh Hendrick. I am a senior solution engineer at Rookout, based out of Los Angeles in the US. My background is in software development. I've been a Java developer. I've done some DevOps work. I've deployed CI/CD platforms across Kubernetes, all sorts of different things. So really happy and excited to be here with you guys today. So we'll kind of jump in and just cover a quick agenda. As Christoph mentioned, we're just gonna have a few slides, maybe 2 or 3 slides early on, and then kind of dive right into the meat of things and get you guys checking out some hands-on stuff, which is typically the most interesting. So really today is about debugging applications within Kubernetes, right? So cloud native development and applications being built for cloud native are really taking off these days. And there's a number of challenges that can go along with that, which we'll talk about and address today. Specifically, when you're trying to debug locally, which you typically do, if you find an issue, you're typically taking the code on your local environment, trying to reproduce and fix the bug. Kubernetes can be challenging because it's hard to mimic the same environment on your local systems that you have running in your production or even later test environments. So we'll talk about that briefly, and then we're going to jump right into a demo. In the demo, we're going to we'll talk about it more in depth in a couple slides, but we're going to talk through a sample application that we have. We'll talk through how we take that application. We've set it up for automatic build and deployment. Nils will talk about that a little bit. I'll then take over and look at how we can dive into remediating a defect or an issue that we find within the application. So we'll kind of debug, we'll fix that on the fly. Hopefully everything works, fingers crossed. And then we'll kind of wrap things up with just a couple slides at the end, just to recap in terms of what we did. So with that, just some high level context setting, right? So if we look really at where we've come from over the past couple years, cloud native adoption is really exploding and taking off. A lot of organizations that we talk to have adopted the microservices architectural pattern. Those are being built out with containers. So containers, I think most organizations are either using containers in production or migrating there, or doing some partial development of containers in production. And then you have those containers being deployed to these dynamic orchestration platforms. Kubernetes is one of them, and arguably the most popular, right? Where it takes your containers, it helps orchestrate them, it helps run them at scale, helps you to scale up and scale down as demand arises. And it really tries to abstract away a lot of the typical running of these back-end servers that you would typically do, and it handles a lot of that kind of behind the scenes, which is really nice. And of course, DevOps technologies are taking off. Development and organization teams kind of working together, automating tasks, CI/CD, all of that kind of stuff. So looking at the IDC, the International Data Corporation, they've actually predicted that by 2024. Cloud native apps will expand to 70% from only 10% of all applications as of 2020. So they're really taking off. More organizations are going to be encountering some of these issues, right, when they're developing and building apps for Kubernetes. So we're going to kind of talk about those and dive into some solutions around those. So just kind of real quickly, a little bit more context setting in terms of some of the challenges that organizations that we talk to typically face when debugging these apps within Kubernetes environments, right? So it's a much different type of development pattern, which requires taking a look at things from a new perspective, using potentially new tooling as well, right? So no longer are you taking the full application that you're building and being able to run all of the components locally. There's much more highly complex architectures, right? Lots of moving pieces, lots of independent components that are running, maybe developed by different teams. and possibly in different programming languages, and they're all coming together. They need to be integrated. And there's lots of points now where things can go wrong, right? And so you can't always have things exactly the way you want it, where you find a defect, you just kind of spin up the application locally on your laptop. You maybe connect a debugger to it and then start debugging. There's too many moving pieces to always make that feasible. With Kubernetes specifically, right, you have dynamic environments. So there's constant spinning up and spinning down of infrastructure. Kubernetes behind the scenes may take down a pod that's not being used, or it may spin up new pods, additional replicas behind the scenes, which makes it difficult to kind of just remotely connect into a machine and find out what's going on. So you need to have better tooling and processes in place, really to make that a little bit easier on development teams and people finding defects. And the last point here, as you guys probably know, bugs can be heavily state dependent and data dependent, which means that when you're trying to resolve an issue, if you're trying to reproduce it in maybe a lower test environment, or by running the service on your local machine even, they don't always reproduce. So what that means is having tools that allow you to get to the bottom of the defect in the environment where they're occurring is even more critical than ever, right? So you have that state and the data in that environment, which is not always easily reproducible in other environments. So those are a couple critical points that we kind of came up with that make debugging a little bit more challenging. Nils, anything you wanted to add to that one?
Yeah, just I can basically second your arguments here. So in terms of tooling, it's actually quite overwhelming if you come to the cloud native world. Basically, like there's the cloud native foundation, basically, which has this landscape picture, and it's just a lot of logos, like over many pages, and those logos are extremely small. I think I will show this maybe later to you as well, but it just gives a rough overview of like how many tools and how much tooling there actually is when you come to the world of cloud native. And then in terms of high complexity, like applications nowadays, especially if you're following microservice architectures, they can grow like easily to hundreds of microservices, right? And it's getting quite tricky to take control of application configuration management with those things, then deployments, and then basically keeping everything in line. So that's a big challenge as well. And then in terms of running Kubernetes locally, yeah, it's possible. I mean, there's Minikube, there's a couple of other projects which support this, but in the end of the day, like your local Kubernetes cluster will be never the same as the one you're running, I don't know, in staging or production, or even maybe a shared development environment. There's always differences for those environments. And then when it comes to dynamic environments, yeah, so dynamic environments essentially is a core competency of the Humanitech features, basically, right? So we are heavily utilizing Kubernetes under the hood and basically make it available to developers to easily spin up just another environment of your current application to test some certain configuration or to test some update. So it can be quite easy with Humanitech and then utilizing Kubernetes to just spin up another environment. And once you're done, maybe even automatically tear it down again after your tests have been run and things like that. And then in terms of in terms of bug reproducibility, like a lot of those issues, they can depend on data or on the state of the application, or maybe even on the load in your production environment, right? So I think it's quite essential that you move some of the debugging you are doing into the cloud environments to be actually fully understand the issues which are happening there. So I don't think like everything is possible to reproduce on a dev or on a testing environment necessarily.
Yeah, absolutely, amazing. So with that, let's kind of jump into the meat of it in terms of what we want to talk about and dive into today. So the demo scenario that we're going to walk through. So Nils is going to take things first off, and he's going to touch on the sample application that we're going to walk through in terms of what we're going to debug. We're going to take a look at the internal developer platform, where we've ahead of time gone ahead and set up some automation around deployments. He'll talk about the build process, the continuous deployment setup that's been configured. So every time we do a code commit, the application will automatically get built, get deployed. And we will probably, as we're going through, discover an issue. And what we'll do is we'll look at how we can actually live debug that application issue real time while the application's running. And then we'll attempt to go ahead and actually fix that code real time. We'll push the fix. We'll go back in using our debugging tools. We'll validate that the fix actually worked. And hopefully this all runs smoothly and we have some time at the end to enjoy some coffee. So with that, I will stop sharing and I'm going to hand it over to Nils to go ahead and kick things off.
All right. Thank you very much, Josh. Let's see. I want to share this window, please. All right. Okay. So you can already see basically the code of the application. So this is my GitHub repository. I forked a nice small Python example app directly from Rookout. I'm also happy to share the link here if you want to take a look yourself. Basically, like a couple of weeks ago, I got in touch with Josh and we developed this idea on how we want to structure this webinar. And we basically decided to like work as a small development team on this application. So we set up a GitHub repository, we set up an Humanitech account, and we set up a Rookout account, and we connected all of those together. So let me give you short introduction to the application. So this is a Python Flask web application, quite simple. If you look into app.py, which is kind of the main file of the application, you can see like several routes being defined. One of them basically being the root kind of, and then rendering an index HTML file. Overall, it's a to-do app, so you can basically like have the possibility to update and submit, so post basically to-dos, and they will be stored and they will be shown on the UI. So it's quite simple and straightforward. What I also want to show you, one thing I added to this application is the Rookout instrumentation. So this is one small change down here, and I believe Josh will talk a little bit more about this as well. But it's essentially when the app is starting, it's also starting Rook, the Python package, which is imported up here essentially. Then on top of this, I mean, this application is containerized. So there's a Docker file, also quite simple, based on Python and the Slim version, basically. There's not much to add for this. And then what's interesting to show is how this application is being built and then pushed to Humanitech. So we are using for this GitHub Actions, and there's a GitHub Action workflow defined for this, which you can find here. And it's also quite simple. Basically, it's using our own action, Humanitech build and push to Humanitech. And I'm passing on a secret, which is the Humanitech token, which is authenticating this CI pipeline with the Humanitech API, telling it that I'm part of the Rookout organization. And then it's basically tagging my latest change. So on any push on master, a new container is basically built and then tagged with build and then dash and then the run number, basically. I think currently we are on build 8. We did a few like smaller changes for testing reasons. All right, so this is how the project looks. This is how the code looks. I will now move over to Humanitech to show you a couple of things there, basically. So let me log in. So essentially, Humanitech is a self-serving platform for developers. So if you're working in a development team and you often come to the point where you maybe need I don't know, a new Kubernetes cluster connected for a new application or a new application environment, or you need a new database and so on, like all those things can be connected to Humanitech. And then basically, if you're creating a new application or a new application environment, those resources will then be issued or used for you for your new application environment. So what we can see here at first, I have some environment automation. So I have this to-do app basically registered here. It's containing one workload. So basically, this is the container which is being built, and based on those automation settings here. So anytime there's a new image update coming in, it automatically will deploy the Python to-do app, so a new version of it. And then on top of this, you can already see like connected resources. So this application is already running and deployed through Kubernetes, and I can basically see like I have a couple of shared resources. For example, the Kubernetes cluster it's running on. I can show this to me as well. And then let's have a look into the application setup, basically. So if I'm looking here into this workload, into this service, the Python to-do app, I can basically see that build 8 of the container, which is tagged with build 8, is basically used. There's a couple of environment variables set, and I believe that Josh will talk a little bit about these because they're also part of the Rookout instrumentation. You can also see, like here's a placeholder variable set, which is essentially a secret. So the Rookout token is stored as a secret within my Humanitech application. I have, in terms of resources, I connected a DNS record basically to my application. So this is just an asterisk domain, and Humanitech takes care of just creating a random string and then .newapp.io for myself. And then I am also defining basically ingress rules where I want to have any traffic which is going to this DNS should be forwarded to port 5000 in the container, because this is the port which is exposed by the container essentially. There's lots of other settings you can do through Humanitech, like setting the service account the application should be running in. You can define file mounts. You can add other applications. Like right now, this application is stateless, so it doesn't store anything in the database, but potentially if you need a database, you can add also databases here. Right now, there's only Postgres visible for me because only a Postgres database is added right now to my account, but there's lots of different possibilities what you can connect to Humanitech essentially. All right. So yeah, so that's the application setup. Let me quickly switch to the running version of the application. Here I can see already container logs coming in from the running application, and I'm also getting the DNS record. So here we see the nice little to-do app for the very first time. So quite easy and straightforward. Testing Rookout is something I want to do. So I'm adding this to my to-do list and it's being saved. So this is perfect. But we not just want to add tasks by ourselves manually. I think there's also a possibility to generate to-do tasks. I will just try this basically. And there's nothing happening. Josh, I think I ran into a bug. Can you imagine?
Dreaded defect.
Let's see. So let me have a quick look in Humanitech. I already can see that in the container logs, which are streamed basically to the Humanitech API, I can see that there's already an error basically, and it seems to be like /to-do/generate is producing an error, and there seems to be some sort of key error. Maybe this can help you in analyzing the issue, Josh. Should I pass over to you and you look into this issue?
Absolutely. Let me take a look into it, see if we can get to the bottom of it.
Awesome.
All right, let me share my screen here. So I have my code base up in VS Code here on my laptop, ready to go. And so let me switch over.
Font size a bit in the editor. That would be great, I think.
Okay, yeah. Once I switch back there, I will definitely increase it. So what I'm going to do is I'm going to switch back over to Humanitech and jump into the application. And so I have my Ingress URL that I can access to pull up the app. And what I want to do to debug this is actually dive into this link here within Humanitech that says Rookout debugging. What this is going to do is this is going to link us directly into the Rookout application, which is going to immediately select the instances where Rookout's been configured that are running within our Kubernetes cluster. And so basically we've tagged this as our development environment. You can see this is our app, our to-do app. And we have 5 instances running, but we're going to be debugging one of those. So this is going to allow us to actually go in and debug the application running in our cluster. So it's remotely running. So you could consider this like a production debugger, if you will, where we're going to come in and understand what's happening within the inner workings of the application while it's running without having to run the code on our local environment or go to a test environment. We're going right to the source of the issue. So what I'm going to do is I'm going to just click next. Notice that it automatically fetched our source code. What happened within Humanitech is that there were a couple different environment variables that had been set. Actually, I'll come back to them in just a second. And what it allowed us to do is tell us where the Git repository is and which commit we wanted to check out. So I'm going to go ahead and go in and I'm going to open up the application code. So I have my Python app here. I'll just zoom in a little bit on this one for you guys as well. And I'm going to scroll down to the method, which was called when Nils clicked that button, the generate to-do function, right? So let's see what's happening there. So I'm just going to click on one of the lines and I'm going to set a breakpoint. So these are actually not your traditional breakpoints that you would see within your local IDE like VS Code. They're more non-breaking breakpoints. So they don't stop the application. Think of it kind of like a snapshot. Whenever line 118 of my code is invoked while my app is running in my cluster, we're going to take a snapshot of data and understand things like all of the local variables, their values. That'll allow us to really get in and inspect that data and understand exactly what's happening real time. So I'm going to go ahead and switch back over to my to-do app. I'll just quick refresh, make sure it works. So we see the task there. And I'm going to click on the generate to-do task. So I just clicked on that and I'm going to jump back over into Rookout. And what you can see immediately is that we got a transaction back. So line 118 was triggered. I can click on it and I can start to inspect all of the local variables, all of their values. So we can see we had an item on our to-do list called testing Rookout, which Nils had added. So we can inspect that data, which is stored in memory. Let's take a look at the response. And I can see there's the URL that's being called to generate that to-do task. This looks kind of funny to me. I wasn't expecting to see this IBM Cloud URL. So let me actually copy this, and I want to just open up a new tab, and I'm going to trigger that. Okay, so we're getting an error message back. So I happen to know this is actually running in AWS Lambda. So it's calling a Lambda function to dynamically generate a to-do task for us. And there's some error happening, right? So I want to potentially be able to come in and fix this. So what I'm going to do is go back to my code base, and let me zoom in just a little bit. And I'm going to dive down to that same function that we just looked at from within Rookout. So I have my generate to do function, and we can see it's actually using a URL, that URL. And if I scroll up to the top of the file, there's that bad URL. So I actually want to replace that. That doesn't look like the right one. I happen to have the one that I want handy right here. And I'm just going to go ahead and replace this URL. And I'm going to save that. And I'm going to actually just open up my browser as well. And I'm just going to make sure that works. So when I call this to-do task, it looks like we get a task back. And the other thing I notice is that the item is called task. If I switch back to my code base and go back down to my generate to-do function again, what we'll notice is that we're looking for an item called to-do. So I'm going to fix that as well. I'm just going to call that task instead of to-do. So that should hopefully fix it. Simple as that. It kind of keyed me into where the issue was. I'm going to go ahead and save that. And I'm just going to go ahead and come back and I'm going to commit this change. So I have one file modified. And I'm going to add this and I'm going to add a commit message, updated app.py with new URL. And we're going to do something a little crazy here and commit directly to master. We're not going to create a pull request. We're going to be rebels here. And so we're going to do that. So we pushed that. We went ahead and pushed that change. And oops, it says. Yeah,
you still need to push. No.
I wrote
push is missing.
I wrote get pull. There we go. Okay, so I pushed that change. So that is going to go and then kick off that GitHub action that Nils mentioned. So if I come back to my GitHub repository and URL, we can look at our actions and we see that it did indeed kick off that that action. So we could actually come in here, we could take a look at it and see that it's actually building and pushing the image. So that's in progress. It'll take just about a minute or so, and then we should have a new build pushed into our Kubernetes cluster.
There's a question for maybe to answer in between. Aaron is asking, is there a way to mask secrets in the snapshot?
Yes, that's a good question. As you correctly saw, we're potentially running in test environments or production environments where there could be sensitive data, PII data. GDPR is obviously a big thing. So there is a way to do that. So what you can actually come in and do is you can come in and perform data redaction. And I can come in and I can redact data within the messages, either based on the name of the variables within your code, and those can be regular expressions, or based on the value of the data itself, right? Let's say you had a credit card number, email addresses, anything like that you didn't want to appear. You can add in those redaction rules, and we'll automatically mask that data so they're not viewable and they're not stored anywhere. Cool.
Hope that answered your question, Aaron.
But great, yeah, great question. So as that is finishing up in terms of the build, I'm just going to come back and look at a few things that we set to make this all work. So we set a Rookout token, which just ties this to our Rookout organization. What we also did was we set our GitHub URL and we set the commit hash that we want running. Nice thing is you could hook this into your CI/CD or build process and automatically fetch the right version of code. So you don't have to worry about what version is running. You get the right version of code when you're ready to debug. And we set a few labels that you saw, which allow us to filter on maybe different microservices or different instances that we'd like to debug. So I'm going to come back. It looks like our GitHub action finished, and we're ready to kind of dive back in and take a look at things. So I'm going to go ahead and just refresh this just to make sure that we got that updated change from the new change that we pushed. So I can see my Python file. It looks like we have the new URL, which is perfect. And it looks like our changes were updated. So what I'm going to come back and do is go back to the application. And I'm just gonna refresh that once. And I'm going to click generate to-do task once. And this time it looks like it worked. We got an item added to our to-do list. I got another message, and we could, if we wanted to, come back in and inspect this data as well and make sure everything looked okay. So we see our Lambda function that was executed. We can see we got an okay response this time. So it looks like we fixed the bug. Everything worked out. So we were able to go right into the source of the issue and get that data, which is pretty cool. So let's just do a quick recap of what we saw. I know we ran through that fairly quickly. Glad everything worked. Sometimes it doesn't go so smoothly in demos. So what we did first and foremost, right, is we had set up the deployment and GitHub Actions, which Nils is going to talk a little bit more about how that all was configured. And then from the debugging side, what we were able to do was immediately gain visibility into the application. So we took that Rookout package that we installed as part of our application. We just did a pip install. We support different languages. So if you're not doing Python, if you're using Java or any JVM-based application, or even .NET, Node.js, Ruby, or Golang, we can run with those kind of applications as well. And it gives you that ability to go in and do exactly what we just did, right? Is do that on-demand debugging whenever you need it, select the microservices or applications. And it doesn't have to be on Kubernetes, by the way. If you're not doing Kubernetes yet, maybe you're doing development on EC2 instances, for example, and just running your applications there, you can still use this as part of your debugging workflows. So then we went in, we set a non-breaking breakpoint to collect some data from the application real time. If we didn't have the right log lines to get the information that we needed, we were able to just insert them on the fly, pull that data out, not have to redeploy the application or do any additional types of code changes. And so it allowed us to debug either locally or remotely in this case, where the application was running on Google on GKE. And it allowed us to kind of get to the bottom of that issue extremely quickly. So Nils, over to you.
Thank you very much, and well done with fixing the issue. That looked good. So quickly to recap about Humanitech, right? So we've basically just seen a small piece of Humanitech in this demo, and I just want to give you the bigger picture quickly of what Humanitech can do for you, basically. So at its core, it's a self-service platform for developers, but also it's a really nice tool for DevOps engineers or platform teams, because what you can essentially do is you can provide all those resources like different clusters, S3 buckets, databases, DNS records, and all these kind of things. You can basically connect those to the Humanitech API through different ways, and then assign those to applications, and then application developers can basically use the resources which have been assigned to their applications. What we've seen mostly was the Humanitech UI, but there's also a Humanitech CLI available to work with Humanitech. Everything is tied together through an API, JSON REST API. What we've seen also is how GitHub Action CI pipeline is basically notifying Humanitech about a new image build. So we are basically post your CI pipeline, right? And we can, like, it's just an API request, a curl request to basically kick off Humanitech and notify it about a new image being available in whatever Docker registry you want to connect, essentially. We have a long list of open source drivers available to connect different kinds of infrastructure, basically. So there's big possibilities in terms of extensibility if you want to connect like very specific kinds of infrastructure basically to Humanitech, which should be provisioned in certain ways with maybe, I don't know, certain labels and certain settings which might be very specific to your whole setup. So this is all possible. And then all the magic is essentially coming together once you hit the deploy button, or once an automated deployment is being kicked off, right? So we have internally, we have this deployment job, and it basically checks like which resources should be provisioned for your application. So it creates a database, it connects to the cluster. Then a lot of configuration can be set inside Humanitech for your application. And basically you have the possibility to have a nice application configuration management through Humanitech, because we are storing everything, like every state of your application in an immutable object. We would call it deployment sets. And then basically like every change would be a deployment delta. You apply a delta to a set, you get a new immutable set, and it stores basically all the configuration, like which kind of resources are connected, which kind of environment variables are necessary, and so on. Everything during deployment time gets injected into a manifest, and then this manifest gets installed into your Kubernetes cluster. And then you have a new application running, a new environment running, and it gets very, very easy to just spin up like dynamic environments. For example, you could think of like a setup where you could basically have a CI pipeline, and when a pull request is opened, then automatically a new environment in Humanitech is being spun up with the right code version of this pull request. Then automated tests can run against this environment, and after the pull request is closed, the environment is teared down again to basically save resources and costs. So that's Humanitech essentially in a nutshell.
Amazing, amazing. So that's it. Are there additional Q&A questions, Christoph?
Cool. Thanks, Josh. Thanks, Nils. I'm glad it worked out. So yeah, we do have some questions, and feel free to drop more questions if you like. That's to the audience. So we have Antoine, who is I think we know each other, right, Antoine? Anyway, so he's asking, do you use VS Code web version in Rookout? He spied a bit.
Yeah. So it's not actually an IDE itself within Rookout. It's built and designed to look exactly like an IDE, so you have that same familiar experience. The code that I opened within Rookout was just read only. So it's not VS Code directly. Looks like an IDE. And allows you to set those breakpoints, but not one itself.
Okay, cool. Next question from AC. Can the debugging UI have role-based access?
Yes, it does have role-based access control built in. So you can assign different roles that way. So we talked about PII, data redaction, and data masking. You don't want anybody to be able to go in and just change those masking rules, right? And see the data in production that shouldn't have access. So as you onboard developers, they come in, you can assign them as admins, which would have the ability to do that, or just kind of regular standard users. Yeah, all of that is very well supported.
Okay, thanks. Another question from James. I missed whether Ruby was supported.
Yes, Ruby is supported. So again, one more time, it's JVM-based applications, including Java, of course, .NET, both core and framework, Ruby, Python, Node.js, and most recently Golang. We're just starting in beta right now.
Yeah, for Humanitech, it's anything which can run in containers and is kind of Kubernetes ready.
Absolutely. Cool. I think so those were the questions. Maybe let's give this another few seconds to see whether people still have questions. We will, as I say, send out a follow-up email with useful links and information. So, and our contact details if you want to continue the discussion individually. All right, doesn't look like there's many more questions. So I think you did a great job in running through this. So yeah, thank you for bringing up the last page. You can see the email addresses, but we'll also share the contact details, as I said, in an email tomorrow together with the recording. Anything you, Josh or Nils, want to add?
No, just thank you to everybody for attending. We appreciate the support and everyone's time. Hope everyone has a wonderful rest of your evening or day, whatever time zone you're attending from.
I could say that better.
Yeah, I highly enjoyed this. This was good fun.
Cool. So thanks everybody for joining, and have a great day, evening from wherever you joined. See you next time.
Thanks, everyone.
Thank you. Bye-bye.